Greetings and welcome, friends. Mr. Waddy and my friends in real life here for you today. This is great. We are all together. We're talking the math. And we were solving systems of equations, and we talked about some special cases in which you might, instead of having a single solution, which graphically would be describing a single intersection of two lines, we talked about when you might have infinitely many solutions, such as when the two lines happen to be the same line, or when there's no solution, such as when the lines are parallel. So here, for this problem, if I want to solve this system, what do you guys think? Subs or elimination? Really? All right, I figured I mean subs because this is already solved for y in that one. But if we did elimination, that's fine too. Notice, for elimination, I would need to get opposite coefficients. Both of these have coefficients of 1. These both have coefficients of 6. So I'd have to multiply one of these equations through by -1 to get opposites. All right, so I'll have negative y equals -1 times -6 is positive 6x. -1 times -8 is positive 8. And so step 2 for elimination method, those y's get eliminated. And those x's get eliminated. And once you have both of your variables, both types of variables get eliminated, that's when you know you got a problem, that you're either going to be in an infinitely many solution or a no solution case. Now let's see, 8 plus 8 is 16. Is 0 equal to 16? No, nope, that's not something I ever taught you. 0 is not equal to 16. Because this is false, that implies this is a no solution scenario. Okay, that means graphically these lines are parallel, which actually, notice that if I was to analyze these graphically, the slope of this line was -6, the slope of this line was -6, and they had different y-intercepts. So that means they were different lines, but with the same slope. That's parallel lines. That's the classic. And so there would never be an intersection. There's no point in common between them. All right, here's 14. What do you guys think? Elimination or subs? You could. Subs would work pretty good. That's a weak spot right there. But actually, I just did elimination the last one. This time I'll do subs, tell you what. So step 1 for subs. You could have done it either way. It doesn't matter. You're not right or wrong. Let's see. So I'm going to solve that equation for that variable. So I would add 3x to both sides. All right, y equals 3x plus 4. If those things are equal, then I can interchange them anytime I want. So I have to plug this into the other equation for y. We're going to have the same result if we did do elimination here. So 15x minus 5. Man, I'm getting a little bit of lag today. 3x plus 4. Is that equal to -20? Or what values of x would make that true? So notice what happens when I do some distributing. Actually, I usually use purple here, don't I? Let's see, what would be bogging down my computer right now? It's thinking hard. It's like it's breathing heavy over here. It's like, oh, you have too many windows open, please. I'm like, come on. Spent a lot of money on you for all that RAM. You better do the work, computer. Right? -5 times 3x is -15x. -5 times 4 is -20 equals -20. And notice when I go to combine like terms, yeah, I think this is going to be an infinitely many solutions. Yes. I'm not sure which, are you talking about this problem? All right. Sorry, I'll have to come back to, I'm sorry, let me finish this thought for a minute and then I'll try to come back. So infinitely many solutions. And the reason we conclude that is our variables all disappeared. That's the same thing that would have happened if you did this with elimination. And because it's a true statement that there are now infinitely many solutions. So which problem were you looking at? For number 9? Well, 10 we just did. For number 9, these ones actually had different y-intercept, or same y-intercept, but different slopes, and since they have different slopes, they're going to intersect somewhere. So this one will actually have one solution somewhere. Because the slopes were different. And if the slopes are different, that means these two lines have to cross. They only can have no solution if the slopes are the same, or infinitely many solutions if the slopes are the same and they're the same line. But number 10 we just saw had no solution because they were parallel to each other. And it was that sort of analysis that showed up in question 18. It said use the slopes and y-intercepts of the graph to determine whether the system has one, no, or infinitely many solutions. So this one's already in slope-intercept form. Let's write this equation in slope-intercept form. How do I solve this for y? Well, don't tell us the answer. Tell us how to do it, right? Minus 12x, minus 12x. No worries, no worries. We just don't want spoilers, right? Yeah, Luke Skywalker, Darth Vader. Don't tell us how they're related. What? They're related? Yeah. I was so disappointed. The worst library book we ever got our kids was like The Amazing Story of Luke Skywalker. And then in a matter of 6 pages, it ruined 6 movies. And I was just like, this is the worst. This is the worst. Oh, man, I was so upset. We didn't even return the book. No, we ended up having to pay the library for it because we lost the book for a while, and then we later found it. But I think I might burn it in a fire this summer. So that's that was Mr. Waddy's book review in the middle of my math video. There you go. So guys, checking at these 2 equations, what is the slope of this equation? Yeah, -6. What's the slope of this equation? -6. The slope is just the coefficient. I can think of these as over 1 if we want, but we don't have to since the denominator is 1. Well, we don't know yet. Since they have the same slope, that means they definitely don't have one solution. Well, we got to keep analyzing. Okay, so what's the y-intercept of the first line? And the y-intercept of the second line? Those are different y-intercepts with the same slope. So that means they can't have infinitely many solutions. They're not the same line. And that they're going to have no solution because they are parallel lines. So my conclusion is no solution because the lines are parallel. Aha! No worries. So, the lines are parallel because they have the same slope and different y-intercepts, okay? Let's look at this last problem. Buying bags of trail mix. A small bag of trail mix contains 3 cups of dried fruit, 4 cups of almonds. A large bag contains 4.5 and 6. Write and solve a system of linear equations to find, here's our variables, the price of 1 cup of dried fruit. So let's let x equal price of dried fruit. Right? Fruit? Nope, that's nope. That's not how we spell. Yeah, or whatever. Yeah, it does look like a V or another R. Who knows? And y will be the price of almonds. So let's see if we can write some equations based off of these facts. So first equation, I think, could be written based off of this. And, and maybe this. Lots of information coming into play here. How could I combine all of that blue information? What's that going to look like? I'm also going to need these. So 3x, so 3 cups multiplied by the price per cup of dried fruit, plus 4 4 cups of almonds multiplied by the price per cup of almonds. That'll represent how much money is spent on, right, fruit, how much money is spent on almonds. Add those together. That will be the total cost, which is the price of a small bag of trail mix, which is 6. I like it. All right, someone combine the purple information here. So a large bag, so that's this one, contains 4.5 and 6. Yeah, how could I write an equation for that? Yeah, I'll kill the fractions later. But what would this be? So 4 4.5 x plus 6y equals 9. To simplify that, 4 1/2 is the same as 2 times 4 is 8 plus 1 is 9. That's the same as 9/2. And I think I showed you guys a while back how to kill fractions. You remember? You multiply both sides by the least common denominator, which is 2. Between 2, 1, and 1, if I multiply both sides by 2 here, I could actually kill those fractions. Oh dear, I'm undoing too far. There we go. There we go. So 2 times 9/2, the 2's would cancel out. I'd be left with the following. I'd have 9x. 2 times 6y is 12y. And 2 times 9 is 18. Okay, so here's one equation. Here's 2 equations. All right, so if I want to solve this, what method are you guys thinking? I don't see a weak spot, right? All of those variables have coefficients in front of them. So let's do the elimination method, I think. All right, so step 1. Let's get opposite coefficients. Between 3 and 9, what number do they both go into? 9. Between 4 and 12, 12. Let's pick the 9. What do I have to multiply 3 by to get 9? I'll write in a different color here. And oddly enough, it works with 12. This is getting suspicious, friends. And, well, this would be a positive 9x. This would be a positive 9x. Let's make that a negative 3. This one already had the 9, so I don't need that. So let's multiply this equation, this blue equation, by negative 3. Negative 3 times 3x, negative 9x. Negative 3 times 4y, minus 12y, equals negative 3 times 6, negative 18. Wait a minute. This is like deja vu or something. What happens when I add these together? Yeah, that's like cancel, cancel, cancel. I get 0 equals 0. True or false? That's true. Oh man, guys, that's so true. You know, it's funny because it's true. It is so true. Classic. 0 equals 0. Man, and because that's true, that means there are infinitely many solutions. Yeah. So that means we actually don't know the answer to this. The answer to this, well, or we know a lot of answers to this, I guess is the problem. The answer is that the price of each is any combination or any positive combination, because I can't have negative prices, that makes, we'll just pick our simplest equation, 3x plus 4y equals 6, true. Let me actually show you what that means, because just because there's infinitely many solutions doesn't mean everything works. It just means everything on the line works, okay? Which is still infinitely many, right? I think it's still pretty good. So here we go. Let me put this in projector mode. Let me drag this up on the screen. So here we go. These are, let's zoom in. Okay, so here are, X was the price of fruit, Y was the price of almonds, and any of the points on this line represent combinations that could make that true. So I could have $1.92 per cup of fruit, and 6 cents per cup of almonds. I could have 48 cents per cup of fruit and $1.14 per cup of almonds, right? There's like infinitely many combinations here. I guess I could technically restrict it to things that are full, penny values, not, it's hard to have 0.3425 in currency forms. Also, I wouldn't be interested in values like this because negative 40 cents, negative 40 cents for a cup of fruit doesn't make sense, as well as negative 34 cents for a cup of almonds doesn't make sense. So I technically, the real world situation would be only those values when x is greater than 0 and y is greater than 0. So it'd be everything on that line. But so notice what I can't have is I can't have $3 for a bag of fruit. That's not a possible point on this line. Only the ones on this line make it true. All right, well, thank you so much for watching, mis amigos de Internet.